before in your science classes. You know things that the measurements are never perfect, or that when you measure things many times, we expect the measurements will be close together, but not exactly the same. One way we know that you're faking your data is if every measurement's the same. Don't fake your data. It's okay. Measurements are never perfect. Just measure it to the best you can every time. Quick review, you know that measurements have units. The units tell you what was measured, right? So we can talk about 9 feet, 9 inches, 9 centimeters. Feet, inches, and centimeters are all units. Units are really important to understanding your measurements. If you tell somebody it takes you 9 to get to school, they want to know, is that 9 hours, 9 minutes, or 9 days? Right? The unit and the measurement, the number and the unit go together, so you have a measurement. In this PowerPoint, units are underlined just to help you remember your units and remind you to think about units. There's some new vocabulary. So our academic language today is precision. Precision is the smallest mark you can measure to, and uncertainty is the smallest amount you can estimate your measurement to. So, what does that mean? So, let's look at some examples. Here's a calendar. It shows January. You can see that this calendar shows the entire month of January, so it measures 1 month. There's about 4 weeks here, right? Almost 5. So the calendar measures 4 weeks, and it measures 31 days. So the smallest unit you can see on this calendar is 1 day. So the precision on this calendar is 1 day. If I had something written like return to school on January 8th, you probably know somewhere on January 8th, I'm back in school. So that might be the uncertainty of this calendar. But if I have something written like stay at Dad's house Friday night, it's going to start on Friday night and go into Saturday morning. So this event, it's probably half a day. And you probably know that sometime at night, I am at my dad's house because it's going from Friday night to Saturday morning. So you can either estimate the uncertainty of this calendar as 1 day or as half a day. Right? You know that it says return to school on the 8th, somewhere in the first half of the day on the 8th, you're going to be at school. If it says stay overnight, somewhere in the second half of the 8th, you're going to stay overnight. Either estimate, an estimate of uncertainty of 1 day or half a day is okay. All right, so the first thing you notice on this slide is that there's a lot more divisions to this calendar. In fact, it looks like most days there's 3 blocks of time. This one's empty, this one's empty, right? So it's still a calendar. It still measures 1 month. There's about 3 weeks here, almost 4 weeks here. There's 28 days. And if every day has a time slot, right, then it adds up 3 time slots a day times 28 days. It's about 90 time slots if we estimate. So the precision is 1 time slot, right? I know what you're doing in the morning, in the middle of the day, and in the evening. Here you're doing something in the evening. Here you're not, right? So the precision is 1 time slot. The uncertainty is probably 1 time slot. That's probably the smallest amount I can estimate down to. If you want to say half a time slot, right? If you know that somewhere between the 5th and the 6th, they're either in this time slot or this one, that's probably okay too. Either estimate of uncertainty, 1 time slot or half a time slot, is reasonable.